Hello everyone. The next factoring method that we're going to learn is factoring using difference of two squares, or most of the time we're going to say DOS, so difference of squares. Now before we start, let's try to define what is a perfect square. So a perfect square is just a square of a whole number. So if we have 1, 2, 3, 4, for example, if you are going to raise each of this whole number into 2, you will get 1 is 4, 9, and 16. So these are your perfect squares. Now, for a variable to become a perfect square, the exponent should be an even exponent. So for example, x raised to 4 is a perfect square variable, x raised to 8 is a perfect square variable, or any variable that has an even exponent. So going back to difference of two squares, whenever we have a perfect square variable minus a perfect square variable, we can factor this as a minus b times a plus b, or it can be a plus b times a minus b. Now let's go back to the worksheet that we did before that has special cases on it. This was the homework that we did on February 26th. So note that here we multiplied b minus 5 and b plus 5. So what happened here, after we used the distributive property, the middle terms here, 5b minus 5b, will cancel out. We ended up getting b squared minus 25. Same thing with 6r minus 4 times 6r plus 4. These two middle terms will cancel out, and we got 36r squared minus 16. So right now what we're doing is the exact opposite. From here, we need to give the factors. So we will have b squared minus 25, and then we have to give the factors, which are b minus 5 and b plus 5. Now note that b squared is a perfect square. 25 is also a perfect square. So whenever we have a perfect square minus a perfect square, then we can use this factoring method, difference of two squares. Here are the checklists that we have to do to check if we can use difference of two squares. First, we always have to check our GCF or GCMF. Check if we can factor out any greatest common monomial factor. Second, do we have two terms? Now, if we have two terms, ask yourself, is the first term and last term perfect square? And it's very important that the operation between the two terms is subtraction. Now, once we satisfied all of this, then we can use this method to factor a given expression. Let's have our first example. Now, do we have a GCF here? X squared minus 25? No, there's no GCF. Do we have two terms? Yes, we have two terms. Is the first term perfect square? Yes, because the exponent is even. Second term a perfect square? Yes, because this one is 5 squared. Do we have a subtraction in between? Yes. So to factor this one out, we just have to rewrite 25 as 5 squared, and then we are going to write x minus 5 times x plus 5. Remember, the formula was, if we have a squared minus b squared, it will be equal to a plus b times a minus b, or a minus b times a plus b. Therefore, we can also write this as x plus 5 times x minus 5. This will be the factors of x squared minus 25. Let's have our second example. 16x squared minus 9. Do we have any GCF between 16 and 9? No, I don't think so. So we don't have any GCF. Do we have two terms? Yes. Is the first term perfect? So 16 is a perfect square because that's 4. X is a perfect square because the exponent is even. Well, sorry, 16 is 4 squared. X squared is perfect square also. Now note that we can write this as 4x squared using laws of exponents. Next, so the first term is perfect. Is the second term a perfect square? Well, that's 9, which is 3 squared. So the second term is a perfect square. Do we have a subtraction in between? Yes. Alright, so now we can now get the factors of 16x squared minus 9 as, I'll just copy this one, 4x minus 3 and 4x plus 3. Now note that this 16x squared minus 9 was written as a squared minus b squared, where a is equal to 4x and b is equal to 3. Now when you write the factors of a squared minus b squared, it should a minus b, a plus b. So that's our a for x, so a minus b, a plus b. Our example number 4, let's skip number 3 and move on to example number 4. Alright, do we have a GCF? I think if we'll be able to get a GCF here between 75 and 12, I think we can divide both of them by 3. So here, 75 divided by 3 will give us 25. And then 12 divided by 3 is 4. So we have a GCF, which is equal to 3. So now, this expression is now equal to 3 times 25x squared minus 4. Next, check if this expression is a difference of two squares. Do we have two terms inside the parentheses? Yes, we do. Is the first term perfect? Yes, because we can write this as 5x squared. Is the second term perfect? Yes, because 4 is just 2 squared. Now, do we have a minus sign between the two terms? Yes, we do. So the factors will look like this. So 5x minus 2, 5x plus 2. So this will be the factors of 75x squared minus 12. Alright, let's do example number 5. Do we have a GCF? No. Two terms? Yes, we have two terms. Is the first term perfect? Yes, it is. And we can write 9c squared as 3c squared. Is the second term perfect? Yes, because we can write 4d squared as 2d squared. Do we have a subtraction in between the two terms? Well, no. So, therefore, we cannot use difference of two squares. Now, since we don't have a GCF and we cannot apply DOS, there's no way for us to factor 9c squared plus 4d squared. Therefore, this is a prime polynomial. Alright? Next example, let's skip example number 6 and let's do example number 7. So, first, do we have a GCF? 32 and 18, I think we can find a common factor between 32 and 18. We can divide this by 2. So we'll get 16x squared. 18 divided by 2 is 9m squared. Do we still have a GCF between 16 and 9? I think there's no more GCF, common factor between 16 and 9. So the new problem will now be 2 times 16x squared minus 9m squared. Now, inside the parentheses, check, do we have two terms? Yes, we do. Is the first term a perfect square? Yes, it is a perfect square because we can write 16x squared as 4x squared. Is 9m squared perfect? Yes, it is. We can write this as 3m squared. Do we have a minus sign between the two terms? Yes. So we can use difference of two squares to factor 16x squared minus 9m squared. It will be 4x minus 3m, 4x plus 3m. Alright, let's do example number 9. Example number 9, check if you have a GCF. So I have S here, but I don't have S here. Now, X and X, so I think we have a common variable. So when we factor out a common variable, we have to bring out the variable that has the lowest exponent. In this case, both X here has the same exponent too, so we can just bring out X squared. So I will have here S4 minus 4. Now again, if you would like to check your answer, x squared times s4 is s4x squared. X squared times negative 4 is negative 4x squared. So we factor out the GCMF correctly. Now next, inside the parentheses, check if we have a DOS, difference of two squares. Do we have two terms? Yes. Is the first term a perfect square? Yes, because the exponent is even. So we can write this as s squared squared. Next, 4 is a perfect square. We can write 4 as 2 squared. Now, between the two terms, we have a minus sign. So we can use difference of two squares. So the factors look like this. So I will have s squared minus 2 s squared plus 2. So this will be our answer.